This is Algebra 1, Homework 7-1. I am Mr. Sindel. Let's jump in. These first few problems are pretty straightforward. They have the same base. I'm seeing a base of 8, a base of 8, so I'm just going to add their exponents because we're multiplying the bases. And this is going to be equal to 8 to the power of 7 plus 3, which is going to be 8 to the power of 10. Each of these problems, I want to be checking my work to be a good model for you guys. 8 to the power of 10, 8 to the power of 10. Let's move on to number 2. I have a bunch of the same bases, same base, same base, same base. And because we have them multiplied, we're going to add all of their exponents. This is going to be 9 plus 8. This is going to be 17. And then 17 plus 3 is 20. So this is going to be 9 to the power of 20. Again, I'm adding 9, 8, and 3. Boxing my final answer. Let's see if I got the right answer. 9 to the power of 20. 9 to the power of 20. I'm on a roll. All right. And number 3, again, I have the same base, so I'm going to add the exponents. And 6 to the power of negative 7 plus 3 is going to be the same thing as 6 to the power of negative 4. But the problem is, in the instructions, I'm only allowed to have positive exponents, and that is a negative exponent. So the trick for this one is you're going to take kind of the reciprocal. It's not really the reciprocal. I'm really bringing this entire thing down to the denominators. Now, 6 to the power of not a negative 4, but a positive 4. And now I can box my final answer. 1 over 6 to the power of 4. Checking our answers. We got it correct. On to number 4. There are 2 ways to do this one. The easiest way is to just cross off this entire term and say that it's 1, which is the equivalent of just scribbling it out and ignoring it. And I really only have to deal with this term. I'm basically done. The only problem is I have a negative power and I need to flip it. So this is going to be 1 over negative 8 to the power of positive 1, which is really just 1 over negative 8. And there's my final answer. Let's check the back. 1 over negative 8 and 1 over negative 8 is indeed correct. We're on to number 5. So remember, whenever you don't see an exponent like you do here, that exponent is a hidden 1. There's one of those v's, and I'm now going to add the 3 and the 1. This is going to be v to the power of 3 plus 1, which is v to the power of 4. Final answer and box it. Let's check the back. Number 5, v to the power of 4. Excellent. All right. And number 6, we finally have some coefficients in front of our variables. Remember that we're going to multiply our coefficients because, again, here, let me do this one a very long way just to make sure that everyone understands. I'm just going to squish everything together. I have 3, and then I have 4 of these x's. 3 x, and then 2, and then x. All right, this is really what this problem is saying. So if I multiply everything together, I can say 3 times 2 right now is going to be 6. And then how many x's do I have? Well, again, you're just adding those x's, or adding the powers, rather. 4 plus 4 is going to be 8. This is going to be x to the power of 8. And my final answer, box it. So my shortcut here is multiply the coefficients, done, and then we're going to add the exponents. Let's check. 6x to the power of 8, 6x to the power of 8. I'm going to use pen so I remember that I did check that work. And moving on to number 7. Okay, this one is a little bit tricky because we are going to group symbols. I'm going to write this out long like I did in number 6. So really what's happening here is I have a 2x, and I have a y, and then I have a 3x, and a y. All right, again, just like we did before, coefficient, oh, that's not a coefficient, haha, 2 and 3 are the coefficients. 2 times 3 is going to be 6, and then let's look at all the x's. I have 1, 2, 3, 4, 5, 6 of those x's, so I'm going to say x to the power of 6, and how many of these y's? I have 1, 2, 3, 4, 5 y's. This is going to be y to the power of 5, and the answer, let's check the answer, and then I'll make sure that I can explain why we can do this. 6x to the 6, y to the 5, 6x to the power of 6, y to the power of 5. So just as a reminder, you're going to group like denominators, like bases. So this is an x and this is an x. Therefore, I'm going to add that 4 and that 2 to get 6. This is a y and this is a y. So I'm going to add 2 and 3 to get the 5. So if it's a different variable, then you like variables and variables that are the same. Those are the ones that you can use your shortcuts on. That'll be true in all future lessons as well. All right, in this problem, I'm going to use that shortcut. Do the coefficients. 4 times 4 is going to be 4 times 4 is 16. And then let's look at all the x's. Remember, I don't see any power here, so that power is secretly a 1. Let's look at all of the x terms and add them up. I have a 1 and a 2. 1 plus 2 is 3. So this is x to the power of 3. What about for the y variable? I have 2 and 2. 2 plus 2 is 4. So this is going to be y to the power of 4. And I get my final answer, which I will box. 16x cubed y to the power of 4. 16x cubed y to the power of 4 indeed is correct. We are on to number 9. Again, I'm going to multiply my coefficients. 2 times 3 is going to be 6. And let's look at all of the next variable that I see is a j. And remember, Remember, if I don't see any power here, you assume that power is 1. Let's go ahead and say this is going to be j to the power of, and then I'm going to add 1 plus the other j term, which is going to be 4. So j is going to be to the power of 5, 1 plus 4. The next variable I see is an h. Let's look at all the h terms. I have an h to the power of 4, h to the power of 4. We're going to add those two because we're multiplying everything together. 4 plus 4 is going to be 8. And do I have any? Oh, I have a k. Look at this k. I haven't gotten that one yet. So this is going to be k to the power of. Okay, let's add all the k's. There's a k here, and there's no other k. So they're just going to rewrite k to the power of 3. K to the power of 3. And that's our answer. So 6j to the power of 5, h to the power of 8, k to the power of 3. Let's check. 6j to the power of 5, h to the power of 8, k to the power of 3. And some students will ask, do you have to write it in this order? For example, what if I had switched the h and the k? So this was k to the power of 3 and then h to the power of 8. That is fine. When you multiply 1 times 2, it's the same thing as 2 times 1. The order does not matter when you're multiplying. All right, in number 10, I'm going to multiply the coefficients 4, and there isn't one. Technically, there's a hidden one. So I'm just going to rewrite the coefficient of 4. Okay, let's do all the j's. I have a j to the power of 1, and I have j to the power of 4. I'm going to add that 1 and that 4, and I'm going to get j to the power of 5. What about k? K to the power of 4 plus 2, because I'm adding these since these bases are being multiplied. 4 plus 2 is going to be 6. This is k to the power of 6. Final answer, and box it. Let's check. 4j to the power of 5, k to the power of 6. 4j to the power of 5, k to the power of 6. We're on a roll. All right, we're jumping into number 11. Let's do the coefficients. Ooh, we got some negatives. Be careful. We have a positive 3 times a negative 3. That's going to be a negative 9. All right, let's deal with all of our x terms, and that's the only variable that I see. All of these are x's. We can add all of these together. 2 plus a negative 2. Well, those are kind of opposite of each other. What I can really do is I can just cross that one off and cross that one off. They cancel each other out. And then what I'm left with is this x to the power of 3, which I can now rewrite as x to the power of 3. And there's my final answer. Again, the long way of writing this is negative 9 x to the power of 2 plus negative 2 plus 3. But that all simplifies down into a 3. Let's go ahead and check our final answer. Negative 9 x to the power of 3 for number 11. Negative 9 x to the power of 3. I'm going to do that in pen, though, for number 11. Moving on to number 12 now. Let's deal with the coefficients first. The coefficients, I only see a negative 2, so I'm going to copy down that negative 2. Let's look at the next variable. I see an a first and a first. Let's go ahead and do our a. And we're going to add all of our powers. I secretly have a power of 1 above that a, and I have a power of 3 above this a. We're going to add those two, and I get 1 plus 3 to get 4. All right, I'm noticing that I have a b to the power of 0. Anything underneath that 0 is going to turn into 1, and that's the equivalent of just scribbling it out, because 1 times this this negative a to the power of 1, we don't have to worry about. So yeah, scribble it out. That's fine. And I'm worried about this negative. I just realized that. I'll come back to you later. And then I have to worry about my b's next. So b, whoa, I double clicked there. My bad. B to the power of what? Well, I didn't have any term there, so I'm just going to recopy this negative 3 right here. So I'm going to say b to the power of negative 3. Now, there's a problem. Technically, this had a coefficient here of negative 1, and that's really how I should have analyzed it. And a negative 1 times a negative 2 should have been a positive 2. So what I'm going to do here is I'm going to erase this negative symbol. I'm not done, because this is a negative power. This b to the negative 3 is going to go into the denominator and become b to the positive 3 instead of negative 3. And what's left over is this 2a to the power of 4, which I will copy down, 2a to the power of 4. Now I have no negative exponents, and that should be my final answer. Let's check. 2a to the power of 4 over b cubed. 2a to the power of 4 over b cubed. We are on a roll. We've got 2 more problems left. Number 13. Let's multiply the coefficients. I have a negative 3 times a negative 2. That multiplies to a positive 6. What about our next variable? I see an m before the n, so I'm going to do another m. And let's see what we have going on here. Technically, this is an m to the power of 1, and this other one is m to the power of 2. Because we are multiplying the bases, we are going to add this power of 1 and add this power of 2 to get a power of 3. The next variable that I see is an n. I see an n to the power of 4 and nothing over here. So I'm just going to recopy this n to the power of 4 right here. This is going to be n to the power of 4. I don't have any negatives happening with my exponents, so I'm done with this problem. I can box that. Let's check our final work, or our answer. 6m cubed n to the power of 4. 6m cubed n to the power of 4. Last problem, number 14, and it is the hardest problem on this entire homework. Let's make sure that we do this correct. I'm looking at coefficients. I'm looking, if there's a negative right here, I would have multiplied that, but there's no other coefficient. It's just a 2, which I will copy down over here. So this is going to be 2. All right, we also have an x. Let's look at all of the powers and add them up. I have an x and an x. Remember, this x is to a power of 1, so I'm going to add negative 4 plus 1. Remind yourself that negative 4 Thank you. Negative 4 plus 1 is the same thing as negative 3, so I'm going to get x to the power of negative 3 here. Now I'm going to deal with all of the y terms. I have a y cubed and a y cubed. I'm going to add their 3 and 3 to get a 6. Now I'm going to deal with all the z terms. I put a line through my z's so you don't confuse them for 2's. I would like you to do the same if possible. And sometimes in college you won't have a professor say z, they'll say z, as in z-e-d. Some countries pronounce that as z. Anyway, I have a z to the power of negative 1 as z to the, there is no other z, so I'm just going to recopy that negative 1 all the way over here, and this is going to be z to the negative 1. Every single part, every single term that has, it's not really a term, every single variable underneath a negative exponent, these are going to be flipped to the denominator. So what's left over? This 2y to the power of 6. Oops, that's not a 6, that's a 3. And the denominator is now x to the positive 3, z to the positive 1, but we don't really write a positive 1. When we have just any power of 1, we just write it as z. And I think that's going to be my final answer. Let's box that and check. 2y to the power of 6 in the numerator, x cubed z in the denominator. 2y6 in the numerator, x cubed z in the denominator. And that concludes homework 7-1 for Algebra 1. Thank you for watching.